In this case study, we're going to analyze a deck of cards and discover how to encode information so that we can use arrays of elements that are encoded. The regular deck of playing cards has 52 cards. There are 4 suits. Each suit has 13 cards in it. There are a number of ways that the information of the card could be encoded. For example, we could have 2 arrays, one that held the card's rank value 1 through 13, and a second array that will hold the card's suit value, spade through heart, and use those 2 arrays together to represent the data. However, that's awkward and error prone. Better is to use one array, but one array cannot hold both numeric data and string data. Because of that, we have to encode cards in such a way that whatever element type we use in the array, it represents each individual card and preserves the information both of the rank and the suit. What we're going to do is number each card with the values between 0 and 51. We assume a deck freshly taken out of its box. It's in sorted order. The suits are in order: spades, hearts, diamonds, clubs. It doesn't have to be that way, but we as programmers have to make some choices, and that's one of them. In this case, each card has the number between 0 and 51. Also, we have an array of 52 elements, which has indexes 0 to 51. So the array is encoding the position of a card in the deck. We always assume the deck has all the cards in it. If we deal, we just simply remember that we've dealt that card and move to a higher and higher index. The element value in the array, again, is a number 0 to 51. That represents the actual card's value. It may be confusing at first when we realize that the sorted deck fits in the array such that the card value and the index value are exactly the same. But if we shuffle the deck, all of a sudden the values are different than the indexes, representing a mixed deck. Once we've encoded these cards with the integer values 0 to 51, we have to have some scheme for decoding them. The way the author chose to do it is a very simple, straightforward manner. If we take the card's value and do a modulus 13 on it, that will return a number in the range 0 to 12. We're assuming 0 stands for ace, 1 stands for deuce, all the way up to 12, which stands for king. So modulus 13 will give us the rank value of the card. The suit value is found by doing a div operation. An integer that is divided by another integer returns an integer value, no fractional part. So taking the values 0 to 51 and dividing by 13 will return a number in the range of 0 to 3. 0 being spades, hearts, clubs, diamonds, 3 being diamonds. So with one single number in the range 0 to 51, we've encoded the value of that particular card, and we decode it by doing a mod operation for rank and a div operation for suit. Now, some students may think, how did that come about? Who came up with that scheme? A mathematician or a programmer who thinks mathematically will eventually stumble on these types of encodings. And the more frequently it's done, the more easily that type of encoding is understood. It takes time, it takes practice. Each time you do it, it improves your ability to do it on your own. It's one of those things that simply takes practice. A mathematical view always helps. To initialize our deck, we simply assign the card value at an index to the value of that index. A for loop can be used where it counts from 0 to 51 and just initializes the element value with that index. Again, that represents a sorted deck as if we freshly took it out of the box. Now we want to randomize our deck, that is, shuffle it. A simple scheme is to start at the first index of 0, generate a random number in the range 0 to 51, and just swap those 2 cards. Then go to index 2, generate a random value in the range 0 to 51, swap those 2 cards, and keep going all the way to the end. Someone may wonder at first, what if if the random number and the index are the same. For example, what if I was on card 23 and I randomized a number and got 23? Would it swap the card with itself? The answer is yes. But that's kind of random, isn't it? That's why this works so cleanly. After being shuffled, we particularly need to be careful to decode the cards appropriately, remembering that we use 0 to 51 as our card value and 0 to 51 as our deck position value. We don't decode the deck position. It's always 0 to 51, 0 being the top card, 51 being the very bottom card. The card value, again, if we do the div and the mod operations, we pull out the suit and the rank. One other enhancement that makes life easier is to keep an array of rank values and suit values that are strings, so that when we decode a card, we can use that number, 0 to 12 as the rank, 0 to 3 as suit, to index into the array and pull out the comparable string value so we can print out the card. If we print out the numeric encoding value of the card, no one would understand it. For example, which card is 43? I don't know. I'd have to do the div and the mod operation, figure it out.